Okay, folks, here we go with part 2 of the video for 10.6 part 2. And what we're asked to do here is solve some trigonometric equations. And the directions here say find all exact answers, then find decimal approximations on the interval from 0 to 2 pi. First equation we're given here is sine of x equals 3/5. Folks, these problems look really simple, and I think once I show you the technique, they will be for you. They will be pretty easy, but there are some things we must consider first, which is why I'm going to ask you to draw a picture. And I know that that frustrates some of you, but I think a picture is worth, what is that? I think I heard it. A picture is worth 1,000 words. So here we have sine of x equals 3/5. So I'm going to start by drawing a picture that would match this statement. So somewhere about right here, I can draw in an angle that has a sine ratio of 3/5. Okay, and if I wanted to draw in the horizontal piece there, I know that it's going to be 4, and I know that this is going to be 4,3. But I really actually, for this type of problem, I don't need to know that. I don't actually need to know the x coordinates, and I don't need to know that horizontal piece. But I can tell you that this angle right here, this is x. Okay, it's the angle whose sine ratio is 3/5. And we're going to be able to find the solution to this problem by saying x equals the inverse sine, or the arc sine, of 3/5. But wait, there's more. That answer is not complete. What happens if x goes all the way around the circle and lands back here, either in the positive direction, counterclockwise, or the negative direction, clockwise? So at this point, I have to consider the fact that this could be plus 2 pi k, where k is any integer. K could be 0, k could be positive 1, it could be negative 1, etc. So this is a solution to this equation. X equals arc sine, or inverse sine, of 3/5 plus 2 pi k. Okay, that is an exact answer to this, an exact solution to this equation. We were then asked to find the decimal approximation on the interval from 0 to 2 pi. So in order to do that, I am going to go to my calculator, and I'm going to say I need to know what the inverse sine, what the heck's that? I need to know the inverse sine of 3/5. And watch what happens on my TI Inspire when I hit enter. It gives me, well, that's not very helpful. It gives me the same thing I just typed in. That's an exact answer, folks, because there is no other way to express that exactly. But if I want an approximate answer on my TI Inspire, I'll just force a decimal point in there anywhere, and it's going to give me an approximate value in radians. And there's my approximate value, 0.6435. So on the interval from 0 to 2 pi, this is about equal to 0.6435 radians. Let me make sure I had that decimal right. 0.6435. Good deal. Okay, so that is our approximate answer, and you deserve a better and approximate symbol than that. So that, I think, is slightly better. Okay, but we're not quite done, folks, because I hope some of you are just screaming at home while watching this and saying, Mr. Vass, there's another angle that has a sine ratio of 3/5. It's over here. Remember that this angle right here could also be x. Okay, that angle will also have a sine ratio of 3/5. So I guess we could call the original angle, we could call that one maybe little x. And if we call that one little x, we should probably call this one big X. Okay? And big X and little x, they are related. And I'd like to show you how. Okay, so big X and little x, let me call this angle right here alpha. and I'm going to say that big X is going to be equal to pi minus alpha. And alpha is really the same as little x, so I can express big X as pi minus little x, which was sine inverse of 3/5 plus 2 pi k. And that, folks, is another exact solution to the original equation. So what seemed really straightforward to begin with has a little added complexity to it. So we have a little x, which is the one that showed up in quadrant 1, and then we have this big X, which showed up in quadrant 2. Why in quadrant 1 and 2? Because our sine ratio was positive. Okay, so the only thing I have left to do for this problem is to approximate that angle big X as a decimal value. So again, I'm going to go back to my calculator. Remember, this is big X is just pi minus what was little x. Okay, so I can just do, for an approximate value, I'm going to do, oh, hold on a second, folks. Technical difficulties. I'm going to do pi minus my previous answer, and there's my approximate value for big X, 2.4981. 2.4981. And let's just make sure if those both fall on the interval from 0 to 2 pi. Well, they sure do, because this is bigger than 0 but less than 2 pi. So is this one. All right, folks, that's it for this example. There are a couple more just very similar to it. Okay, folks, for this problem we were asked to solve for x, and we were given secant of x equals negative 13 over 5, and I'd automatically like to rethink this as cosine of x equals negative 5/13. Cosine x equals negative 5/13 means this thing is going to show up in quadrant 2 when x is going to show up in quadrant 2. We're going to have something that kind of looks like this. Okay, so this is the angle whose cosine ratio will be negative 5/13. And we can then write the solution to that equation as x equals the inverse cosine of negative 5/13. Don't forget to add 2 pi k there, because we're going to have to consider revolutions about that circle both in the positive and negative direction. Let's go ahead and find an approximate value for that on our calculator. We'll do that right now. So we're looking for the inverse cosine of negative 5/13, and I'm going to go ahead and throw a decimal point in there so I get an approximate value, and that's 1.9656. 1.9656 is my approximate value. But we're not quite done there, folks, because I have there's another angle whose secant is negative 13 over 5, and that's going to be one down here. Okay, so we're also going to have an angle down here in quadrant 3 whose secant ratio is negative 13 over 5, and or whose cosine is negative 5/13. So this one, maybe I could call this, in the last example I did big X and little x. Maybe this time I'll call it top X and bottom X. Okay, and the top X has this solution. Bottom is going to look slightly different. So now I got to think about the geometry between these two x's. So the top x is here. Looks like it could be, we could think of this as a positive angle, The bottom x down here, it's just a reflection across the x-axis. So this really here is just the opposite of x. It's kind of symmetric to the original x on top. So if this is x radians here, this is negative x radians here. And my solution is just simply going to be the negative inverse cosine of negative 5/13. We don't want to forget about revolutions around the circle, both in the positive and negative direction. So let's go ahead and figure out an approximate value for this. I'll go back to the calculator. Not there, wrong button. Okay. Now I want the negative opposite of that, and that's going to give me negative 1.96559, which is just the opposite of what we had before, but we were told that we want our answers to be between 0 and 2 pi. So let me take 2 pi and add this value. I get 4.31476, and that is my final answer. 4.3, and I forgot the numbers. 4.3176. There you have it, folks. Okay, so we're done with those two examples. Now we're going to move on to one that's slightly different. I wouldn't be doing it unless it had something unique and slightly different than the previous two. So now we have tan x equals 5. So the first thing I want to do here is think about tan x. When is tangent of x positive? It's positive in quadrant 1 and quadrant 3. I'll go ahead and draw an angle in quadrant 1. Probably looks something like this. Tangent ratio for this angle, this is x. The tangent ratio for this angle is 5, or 5 over 1. So I can think about this value here is 5. This is 1, opposite over adjacent, 5 over 1. So the value of that angle x equals the inverse tangent of 5. And we have to consider increments around, full revolutions around the circle. So I want to write plus 2 pi k here. Now, folks, don't write that down just yet, okay? Because there's something here that we're gonna modify in just a second. So don't write that down just yet. Let's think about what happens down in quadrant 3. To the other set of angles that have that same tangent ratio of 5. Okay, so I have the opposite over adjacent ratio of 5 to 1, and there's something interesting about from this angle to this angle, and I hope you remember that those are pi radians apart. So if I have the tan of inverse tan of 5, and I add pi to that, I end up down here in quadrant 3. So my final solution for this one can just be the inverse tan of 5 plus pi k. And that includes both the angles in quadrant 1 and in quadrant 3. So let's go ahead and get an approximate value for that now. Oh, by the way, that's our final answer there. We'll get an approximate value. We got to find anything in between 0 and 2 pi that satisfies this equation. So we should come up with 2 decimal approximations here. So let's find. Let's do the inverse tangent of 5. We want a decimal approximation. So we get 1.3734. 1.3734. And then let's add pi to that to find our bigger angle, the one down in the third quadrant. So we're going to add pi to that previous answer. And we get 4.51499. If we round that to 4 decimals, it's going to be 4.5150. 4.5150. Okay, so those are our decimal approximations that represent the two solutions between 0 and 2 pi. Folks, that's it. I hope you find these examples helpful when you get into WebAssign. Good luck, and if you have any questions, you know where to find me.